Now, a slight hiccup that I might throw at you is not giving you just the balanced chemical equation. It will still be a balanced chemical equation, except instead of the actual chemical formulas, it'll be stick diagrams or Bohr diagrams. When I give you the chemical reaction in this way, as you'll see on the next slide, we have to flip around the calculation so that for these type of reactions only, we have delta H as reaction equals reactants minus products. We do need to look at a different table for this, as we can't just look up the substance, we need to look up the specific bonds that are present. So, in the reactant side, we take a look, we have what is basically C2H4. I have the two C's with a double bond, that's what the two lines mean, and then 4 single bonded CHs. So what do we really have in this substance here? Well, we have a C double bonded to a C, that's one type of bond, and we have 4 C bonded to single H. The other substance we have as reactant is H2, given to you as HH, which is a simple bond to look up. So now we need to go and we need to look up these bonds in the bond enthalpy table. As I said, it's a different table. Again, making sure that you pick the right one. A C double bonded to a C is not the same as a C single bonded to a C, but that C double bond C has an enthalpy of 614. The CH bond, just like before, we need to account that there's 4 of them. Looking that up, each one of those is 413. We get a total of 1652 on that one. And looking at the HH single bond, that is 436. Total those all together, we get 2702 on the reactant side. Likewise, we have to do the same thing on the product side. Now looking at this substance, it's C2H6, but the way the bonds are presented, we have a single CC bond, and then we have 6 individual CH bonds. So looking up a CC single bond this time, keeping in mind that this single bond on the product side is not the same as the double bond on the reactant side. The enthalpy for the CC single bond is 348. A CH, there's 6 of them, and again a CH bond is 413. Multiply that by 6, we get 2478. Total that up and we get 2826. And since this was given to as bond enthalpies, there's a stick diagram. The delta H of the reaction is delta H of the reactants minus the products. And I can't be clear enough on this fact that we do need to do reactants minus products for a stick diagram, but for the chemical formula it has to be products minus reactants. So reactants 2702 minus products 2826, and we get a total of negative 124, and again the units are still kilojoules per mole. And again, since delta H is negative, this is an exothermic reaction.